So let us start the sessions for this induction program. To deliver the first session, we have with us Dr. Nagarajan Govindan, who is a professor at the Department of Mechanical Engineering. And we are very happy to have him here. He has his BE, ME and PhD from Anna University, and his areas of research include fuels, biodiesels, and several other important areas related to this field. I request our esteemed director, Madam Dr. C. Umarani, to felicitate Professor Nagarajan for accepting our invitation and coming here. We are very glad that you are here, sir. I also request our director to present sir with a small memento as a token of our love and appreciation. I request Professor Kumarasan also to join. Thank you for accepting our invitation, sir. Sir. Thank you, sir. Over to you, Professor.
Yeah, thank you, Dr. Shobha, for your kind introduction. Director of Research, ma'am, Deputy Directors, Dr. Kumarasan, Dr. Shobha, and the research scholars from various institutions. I'm extremely happy to be here. And first of all, very good morning to all of you. Please accept my congratulations for joining Anna University as a PhD scholar. And you are into the Anna University family, one of the famous universities in India, of course, in some part of the world as well. Well, I'm very happy to be here to share my experiences, what I have gained for about 35 years, working for an industry as well as for Anna University. I'm going to retire in about 8 days' time. That is, next Friday I'll be retiring. So possibly what I would take you through for about an hour. Maybe the time as per my watch is 11:28, and probably around 12:30 to 12:35 I would be stopping my talk, and possibly I expect some interactions. So what I would love always, like in the classroom teaching, is that there should always be a two-way communication, not like a dialogue wherein I just keep talking and you just keep quiet and finally we get away. So that won't serve the objective of organizing this induction program. So induction program is mainly for having some kind of interaction in order to have some kind of understanding on what the topic, what we are going to talk about. Well, the topic that has been given to me, or probably I preferred, is the research design and methodology, which is very, very important. And as you know that it's a 3-day induction program, and I happen to be the opener of this 3-day match, which means that I need to bat well so that I set the tone for the next 3 days. So possibly when Madam requested me last week stating that, can you give a talk on research design and methodology? Yes, I said, okay, we can talk about it. But when we wanted to formalize it in the form of PowerPoint, okay, and you organize the points, okay, so that's where, I have taken the help of the internet in collecting certain points. Of course, I have added my experiences also into this PowerPoint. So that's where we are. And can see the topic is research design and methodology. So I understand that there are about 800 PhD scholars, and out of that about 100 plus are here at the moment, and the remaining are participating through online. So in Anna University, we work on 3 different areas, and that's what I have put it as STEAM. S stands for science, T stands for technology, E for engineering, A for architecture, and of course, M for, usually we have management, but there might be some PhD scholars who would be working on mathematics. They shouldn't feel that they have been left out, so I have added mathematics 2 in Yan. So STEAM is what is the major area in which, all of you would be pursuing your PhD for the next 3 to 4 years. Well, maybe before we get into the subject, so I would like to give the perspective of various personalities as well as the dictionary's definition on what exactly we mean by research. So you can see that I will start with Oxford's dictionary, which defines research as the systematic investigation into and study of materials and sources in order to establish the facts and reach new conclusions. And as put forth by Redman and Morey, research is a systematic effort to gain new knowledge, a careful investigation for new facts in any branch of knowledge. Research that refers to a search of knowledge is defined as a scientific and systematic search for pertinent information on a specific or a particular topic of your interest. Research gives an opportunity to work on technical problems and bring out solutions. That's where today we talk about, if you look at the industries are talking about design thinking, wherein, they want the engineers to come out with innovative solutions for some of the challenging problems that they face on a day-to-day basis in order to provide good things for the humanity. So bring out solutions by following, again, scientific and technical methods and by applying the theoretical knowledge and analytical skill gained over the years. Scientific methods usually consist of systematic observation, classification, and the interpretation of data. So if you look at it in general, if you look at all these things, and finally it will boil down to research is a systematic way of doing things. So whatever you try to do, you have to do it in a very systematic, planned manner, and accordingly you can very easily execute that. So according to Clifford Woody, research comprises defining and redefining problems. Probably I will go through this, and maybe later on as we progress, I will discuss in detail on how exactly we have to start the research work and where to end it. Defining and redefining problems, formulating hypotheses and objectives, collecting, organizing and evaluating the data what we have collected, making deductions and reaching some kind of conclusions, testing the conclusions to determine whether they fit the formulating hypothesis or objectives. Now, if we look at the research is could be characterized into two. One is pure research, the other one is applied research. Pure research is the one where we involve in developing and testing theories and hypotheses. For example, if you look at the people who do research from the academics, but I don't know how many of you are full-time research scholars and how many of you are part-time research scholars who work for various engineering colleges or institutions around. So when we look at, let us be very frank in saying that, those who would like to pursue the PhD from the academic institution will be more interested in doing pure research, mainly because of the reason that at some point of time, we would like to become either associate professor or a professor. Okay, because, the norm says that only when you have a PhD, you can reach to the level of a professor. So that's where we try to do pure research, right? And knowledge produced through pure research would add to the existing research method. So that doesn't mean that, okay, whatever research that you do, right? So maybe to get your promotion, but that doesn't mean that, okay, it is mainly for promotion, but you also find that, this would be an added information to the scientific community. So which means that we are supplementing the research data to the world. The second one is the applied research. So mostly you will find that the applied research would be done by the industries. Okay, so as academics, we will be focusing on pure research, but if you take the case of industries, when I say industry, I mean that it is only the industries in India. Right? So where they focus on applied research, meaning that, whatever research work that they do, and ultimately you will find that it will end up with a product. Okay, but this is not the case in developed economies, wherein you will find that both the pure research as well as the applied research happen at the university level, wherein you will find that all the industries will have a tie-up with any of the institutions or universities located in that country, and together, and you will find that there will be sharing or dissemination of information between the academics and the industry people, as well as sharing of resources by way of testing the products at the university level with the facilities available in the laboratories, and as well as you will find that the faculty members would be visiting the industry so that they can do the testing on the engine and on the bed or probably on the field. So this is what I mean by the applied research. So when you have when you are pursuing your research, you should have two things in mind: whether you're going to focus on pure research, wherein you just provide the data for the scientific community, or you would like to have your product evolved ultimately as a product. Okay, so I have put it this way: there are two ways of doing research, and research need not be always innovate or finding out new things. It's not so. And you can see that there can always be an improvement in the process, whatever we have in the industries, whether it is a chemical industry or a mechanical industry or an auto industry or an aero industry or a building construction industry. So always there is a scope for improvement in the processes. So that's what you can see that I have put it as research, which means that you have to search again. Now here again, I would like to give an example, like very common. Of course, I am an automobile guy, so I would like to give an example wherein you can very easily understand this. When I was a student about 35 years back in the same institution, we used to have a two-wheelers which used to give only about 25 to 30 kilometers per liter. But today we have two-wheelers which are capable of, I'm talking about petrol engine vehicles, not the electric vehicles. So today we have two-wheelers which can give about 65 to 70 kilometers per liter. So which means that there is improvement in process. There has been an improvement in the process in terms of minimizing the losses and improving the product by means of advanced technologies. From mechanical system, we have moved on to electronically controlled systems, and all these things have resulted in improving the performance of the system. Anything for that matter, like for example, if you take the case of air conditioners, right? So we have split air conditioners, okay, which used to consume a larger amount of current of about 7 to 8 amps. But today we have air conditioners of the similar capacity which will be consuming only about 3 to 4 amps. Possibly you might have seen in the market, like you have a 3-star rating air conditioners, 4-star rating, 5-star rating. So when we go for 3, 4 and 5, which means that the current consumption is going to be lower and lower. So what I'm trying to say here is, and nobody is reinventing the wheel, like, nobody is going for, inventing an air conditioner, which is already there. But only thing is, we are trying to improve upon the process so that, you improve the efficiency or improve the performance of the system. So that's what is research. Then the next one is, of course, you come out with new ideas of products. And that's where, we talk about innovation. Now, here again, I would like to say that until about 10 years back, the industries, our Indian industries, never used to work on innovation. We always go for research. That means that whatever technologies that were available elsewhere in the developed nations, those technologies were brought into India and they were modified to suit the India's requirements. So it's research. But today, if you look at it, it's totally different. The industry scenario is totally different. And if you look at any industry, you will find that there will be a separate department called as the NPD, New Product Development Department. And that is where, we talk about innovation. Well, again, if you look at research, it could be quantitative or qualitative. Now, most of the time, we will be talking about qualitative. Like, just to give an example, I think that, okay, in my class, my students' performance is good. This is only qualitative. But I say, in my class, my student, the average pass rate is about 95%, so I am quantifying. So depending on what type of work that you choose, what topic that you choose for your research, it could be classified as quantitative or qualitative. But invariably, from my experience, it's my perspective, so wherein you will find that those who work on management, or in social sciences, you will find that they will all be only collecting data and analyzing it, or even people from the commerce group. Okay, they will all be collecting data, analyzing it, and put forth with the hypothesis. Okay, it's qualitative. But somebody who is really interested in doing work on mathematical modeling or simulation of systems, or do on some experimental work, you really collect the data. That becomes quantitative. So these are the two major classifications of research. It could be either qualitative or quantitative. Like possibly you might come across somebody would have written a review paper. You will come across when you do your literature survey. So when we write a review paper, so what we try to do is we collect the information in a particular area, right? In that particular area, whatever research work has been done, I try to collect that and collate it, and I present it in the form of a paper called as a review paper. Okay, but when I present as that becomes a qualitative one. Okay, but when I do a work on my experimental setup and I publish a paper based on the data, which means that I am talking with the confidence that yes, this system can improve the efficiency. That's quantitative. So it means that I am confident about it. Okay, so that's it. So when we look at the research design, so you would find that this pointer will not work on this. This screen, the pointer will not work because it's LED, right? Okay, doesn't matter. Okay, so the researcher examines the various variables while including the numbers as well as statistics in a project to analyze its findings. Probably if you look at the quantitative research design, you would find that we make use of graphics, pie charts for data collection, measurement, and analysis. Qualitative is, you can see that it is explanatory in nature, always seeks answers to what has been done, how it has been done. It mainly focuses on why a specific theory exists. Like I always used to say, to my students that you should always, anything that you try to read, and you should always have this in mind, 5W and 1H. Who, when, what, where, which, and how. We'll come to that a little bit later. So that's what you can see, what's and how's. So it mainly focuses on, why a specific theory exists. And when we ask a question to somebody, what is the response of, like for example, possibly if you look at some of the people who do research in the management area will send questionnaires. So that is for data collection and finding out the feedback from various people so that they will analyze after getting all the data from various people. Okay, and sometimes, they will be even interviewing, personal interview, like they'll be posing questions and things like that. So that's what it is. And that would allow a researcher to draw a conclusion with proper findings. So which means that based on questionnaires, based on interview or a face-to-face interview, so you would find that you will be able to arrive at some kind of a conclusion. And when you take the case of qualitative research design, you would find that mostly the case studies. Right? I've seen, some researchers are working on, case studies. Get some case study and try to find out what are the problems, okay, that have been faced why this product has failed and what are the ways in which, we can try to improve upon in order to set right the product and put it back into operation. Okay, so coming to the main part of research. So as I told you before, the research could be either theoretical modeling or it could be experimental. We will be discussing in detail more about that. So most of us feel that, why should we soil our hands? Why should we toil in the laboratories, okay, in order to, do the experiments? So instead, why don't we sit in a computer laboratory and try to do some kind of a mathematical modeling, because we have a lot of modeling tools available, and name whatever area, whether it is civil, mechanical, electrical, electronics, or computer science or management, you find that a lot of software packages are available wherein you can work on mathematical modeling. And today, with computers, we have, you can generate a 3D view of your system, and you can, whatever way you want to rotate, like in those days, we used to do it in the form of a drawing sheet wherein, we used to draw the perspective view, the front view, top view, right side view, left side view, so on and so forth. But nowadays, with computers, you don't have to do all those things, wherein, you can rotate the component in whatever way you want, and you can have a view of that. If you want the side view, you can always get the side view. If you want the plan, you can always get the plan, making use of computers. But people have a feeling that, okay, if you make use of computers, if you make use of software packages, it is easy for us to do the research. It is not so. In fact, doing a theoretical work as part of your research is much more difficult than the experimental work. Because experimental work, you can generate the data, okay, plot the results, and now you can find out what are the reasons for the deviation, what are the reasons for the variation. But when you do a theoretical work, you need to give input. Unless you understand the physical mechanism that is involved in it, you may not be able to really come out with a good theoretical amount of work, where you'll find that towards the end, you would find that the results won't converge. The results won't converge. Okay? And what is important in theoretical work is that, validation. That is, you need to validate your theoretical modeling results. There's no point in, having a mathematical model which gives an efficiency of about 110%. Nobody is going to accept that. Okay, so how do we validate this? That's very, very important. Because you need to validate your mathematical model, because computer does not know. Whatever input that you give, it is going to compute and it is going to give out some values. So how are you sure that, okay, whatever the computer gives is very valid or more closer to the actual ones? So this is where validation is very, very critical when you go for theoretical modeling. Okay, and there are many ways in which we can validate. If possible, you can do some kind of experimental results. So suppose, let us say that, you work on about 5 to 7 parameters to be varied, okay, in your input, and you want to study the effect of varying these 5 to 7 parameters on the output of the system. Okay. Now, it is not possible for you to vary all the 7 parameters on the experimental setup and finally validate. Okay? It's enough if you validate any one of these parameters. Like, for example, I would like to just give an example based on our experience from my research area. So wherein, I am a combustion guy. I work on combustion engines, petrol and diesel engines. And when we do simulation or mathematical modeling of internal combustion engines, we try to find out the performance in terms of what is the torque that is produced by the engine, what is the power that is produced by the engine, what is the efficiency that is given by the engine, and what are the various pollutants that come out of the engine. So all these things could be modeled. But how we validate the model is we generate a very simple pressure crank angle diagram. So we measure the pressure inside the cylinder, we measure the time, pressure, time, okay, which can be very easily obtained from the engine. Now superimpose this experimental pressure time diagram over the obtained theoretical pressure time diagram. If it is well within, say, about 5 to 10% error I am talking about, I can be assured that whatever output that the model gives, I can be taken for granted. So once again, I would like to say that, you don't have to really, validate all the parameters by performing experiments. If you have one or two, that is more than sufficient. Okay, there is a possibility that, certain problems or you may not have facilities for carrying out, some kind of experimental experimental work, and possibly there you can have some kind of a calculations done so that to match your to your theoretical results. In case, even if you are not able to perform the hand calculations or manual calculations, there's nothing wrong in going for literatures, wherein you can always refer the literature. Okay, just to give an example here again, that's what a lot of people who work on the computational fluid dynamics CFD, who does this? So computational fluid dynamics software is a very complex software wherein, we can analyze the system. Like for example, let me say that I would like to design an air conditioner, for this auditorium. So I need to determine what should be the capacity in terms of the tons of refrigeration, whether this hall needs about 50 tons of refrigeration or 100 tons of refrigeration. So how do I find out that? So I need to find out how many lights are there, how many fans are there, how many such lights are there, and how many people are going to be accommodated. So I need to take into account all the heat generated by all the system and the people. And I also need to have the design in mind in such a way that I need to have uniform circulation of air all around this auditorium. So how do I design that? I cannot do that experimentally. Okay, so this is where actually the CFD software comes into picture, wherein I can mathematically model, visualize how the velocity distribution is, how the temperature distribution is, how the humidity varies across. Now, all these things can be modeled by means of computational fluid dynamics. Okay, now, how do I validate for such a big auditorium? So possibly I can have sensors located at different points to measure the pressure or temperature, whatever, water vapor, whatever. Okay, in case I have difficulty in measuring this, possibly I can take somebody else's work, okay, whose geometry is very similar to that of my geometry in which I try to work on. I can feed in the input of someone else who has done the experimental work into my model, and I can generate the output, and I can try to now compare my model with that of the experimental one. If that matches, I am sure that, okay, my model is good. So that is what is the third point, where you can see that from the literatures, you can validate your model. Nobody is going to question that. But what is important for theoretical modeling is validation. Okay, so experimental, of course, it's not that easy. You need to spend a lot of time designing the experimental setup. And you can see that when you talk about experimental, you require some advanced level facilities. Okay, and of course, it's going to be expensive depending on what type of problem that you choose. And what is important in experimental work is the error analysis, because we know that different instruments and analyzers are going to have different kinds of, accuracies. So we need to have some kind of, error measurement, error analysis or uncertainty analysis. Just to give an example here, now let's say that I am trying to improve upon the efficiency. Like, let's say that, I was talking to you about a two-wheeler which gives about 70 kilometers per liter. Now, I say that I have improved the process wherein I get an extra mileage of about 1 kilometer per liter. That is, instead of 70, I get 71 kilometers per liter. But the cumulative error of all these systems, instruments, analyzers, whatever I make use of, gives plus or minus 2 kilometers per liter. It doesn't make sense. I say the error itself is 2 kilometers per liter, and I claim that, my system has improved by about 1 kilometers per liter. So this is where those who perform experimental work, you have to perform the error or uncertainty analysis. Right. So, coming to why do we do research? Okay, so you can see, as I told you before, desire to get a research degree along with its consequential benefits by way of, getting promotions or whatever. Desire to face a challenge in solving the unsolved problems. Desire to get intellectual joy of doing some creative work. Some will have passion, They might be doing research. Some will have passion. I will come to that a little bit later. So that is, joy of doing some creative work. Desire to be of service to society. That's very, very important. We are sitting in a beautiful environment wherein the temperature is maintained about 25 plus or minus 1 degree Celsius. You just get out of this, you will find that you are in an oven. Okay, that's because of the reason, we have some kind of, work has already been done. So we are living very comfortably today. Desire to get respectability. Directives of government, employment conditions, etc. Because as I told you before, we have norms stating that unless someone possesses a PhD degree, you can't move up in the ladder in the organization. Not necessarily in the academic institution, but also in the industries too as well. Validate intuition, improve methods, which I already said. Of course, demands of the job, and of course, for publication and patenting. Now, moving on to the important topic, how do you choose a topic? It's very, very critical. It should be based on an idea. Possibly some of you must be having something in your mind stating that, okay, why don't we do like this? So possibly that could be an idea. Or maybe based on your experience again, possibly you would have come across, while talking to people or working on some systems, probably you would have thought that, okay, why it has been done like this, why not like this? So that's it. And of course, in case if someone doesn't have, any kind of idea, possibly, based on the literature survey, you can just, try to look at various literatures. And again, for looking at various literatures, you need to be very careful in identifying a broader area initially. You don't have to be very, very specific to start with. You can have a broader area. Okay, so coming to the design of research, that's very, very important. Okay, and it's a set of advanced decisions that make up the master plan. So you need to plan your work in advance so that you can save on time, you can save on costing. which I miserably failed when I registered for my PhD in 1992. As soon as I joined as a lecturer in the Department of Mechanical Engineering, Anna University, with over enthusiasm, as soon as I took up the lecture in mechanical engineering, immediately I registered, in spite of the fact that then head of the department advised me, Nagarajan, you have just joined and you need to settle down in Anna University. You may have to take about 2 or 3 courses per semester. Then, you have to get accustomed to this system and all. We never listen to others. Okay, so likewise, I never listened to him. I said, no. I would like to register for my PhD. Okay, so I will come to that a little later on, sharing where I failed miserably initially. Okay, so which means that you need to have a plan, okay, so that you save on the time. So research design is simply a structural framework of various research methods as well as techniques that are utilized. So why research design is important? So you can see that good research design is the first rule of good research. Knowledge of the needed research design allows, as I told you before, advanced planning so that the project may be conducted or your work may be conducted in less time and typically at cost savings. That's what I said. The objectives of research design are to gain background information and to develop hypotheses, to measure the state of a variable of interest, to test hypotheses that specify the relationship between 2 or more variables. So in many cases, you will find that research becomes an iterative process. That is, when you try to do something else, you will find out that, okay, you may have to do something else, okay, in order to arrive at the results for this particular research. So in this way, it becomes an iterative process wherein, for doing your major research, probably you will have to do some kind of small researches taking place at different levels sometimes. So the features of research design, or you can see that as I told you that you need to have a plan. And for that, you need to specify the sources and the types of information related to the research problem. A strategy, which approach will be used for gathering and analyzing the data. The time and the budgets, the most important. And these are the constraints. You need to squeeze time, and especially those who are working already and those who have registered for PhD under part-time, then you will have to find some time for carrying out your research. So this is where actually major planning is required. So some of the elements of research design are method applied for analyzing the collected data, type of research methodology, accurate purpose statement, probable objections, constraints for research, techniques to be implemented for collecting and analyzing the data, measurement of analysis, settings for the research study. Now, what is important is defining the objectives. This is very, very important. Okay, this is very, very important. Try to keep this simple. Don't feel that in about 5 years' time, I am going to land on Moon or Mars. So the objective should be as simple as possible. At the same time, it should be as creative as possible. It shouldn't be a repetition of what others have already done. Why I said that it should be simple is, if you have too many variables, it will take a long time. The more variables, the more difficult. So defining objective is very important because it determines the data to be collected, because you are not going to just determine the objective and straight away you're going to get into the work. Okay, once you have the objectives in mind, then you need to find out whether a similar type of work has already been done. And you need to collect all the information pertaining to that. You need to collect the characteristics of the data, what are the relations to be explored, choice of the techniques to be used in these explorations. So all these things need to be set. Now, Steps involved in a research, choosing a subject. This is very, very important. Like, for example, I would like to give you, to start with, conventional engineering areas like civil engineering. Now, if you look at civil engineering, we have remote sensing, we have soil mechanics, we have structural engineering, we have water resources, we have environmental studies, environmental management. So like this, we have different areas. If you take the case of mechanical, we have three different areas, namely the design, the manufacturing, and the thermal. Again, if you look at the thermal, we have we have three variants, namely internal combustion engines, and we have refrigeration air conditioners, then we have energy. Okay, if you take the case of, computer science or IT, we talk about artificial intelligence, we talk about IoT, we talk about machine learning, we talk about network security, data mining. So you find that we have different areas are being covered in different major domains. So you have to choose a subject or a topic of your research based on your interest falling under any one of these categories. Once you have chosen a topic, what is important is the literature survey. Because literature survey is very, very critical in the sense that, literature survey is going to tell you that what kind of work has already been done in this domain. As I told you, you can't say that, no, now I have come out with the air conditioner. There's no point. If you can come out with something like a new refrigerant, wherein instead of using about 1.5 kilograms of this R32 refrigerant, I am going for something else. So far, no one has used it. And today, if the world over, people are talking about, electric vehicles. Electric vehicles are not new. Electric vehicles were there as early as in 1905. But only thing is, because of the advancements that have taken place in the area of electronics, control systems, sensors and actuators, today we are able to have a beautiful vehicle on road. Even if you look at the design of the system. So, anything you need the same basic components, but only thing is you need to have some kind of improvements. So, how you can add your contribution, how you can find out that whatever idea that you have in your mind, hasn't been implemented so far. It's only the literature survey, a thorough literature survey, that is going to give you an idea that so far nobody has contributed this. I'm going to give an example of that, don't worry about it. So defining and formulation of specific objectives, as I told you before. Of course, preparing a synopsis, meaning that, it's not the final synopsis, you mean to have that there. You should have some kind of an abstract on what is that you have proposed to work on. Then, of course, based on that, procuring suitable apparatus and materials. Design of experimental setup. You need to perform some kind of a preliminary experiments. And, of course, the execution of the major part of your research. Accurate measurements and data collection. Data analysis. So once you collect the data, you need to analyze and you have to interpret, you have to reason out. That's very, very important. So invariably, I have seen some of the theses which have come to me for evaluation from universities outside Tamil Nadu. So wherein, it'll be like a laboratory record notebook. If this increases, this decreases. If this decreases, this increases. That's not the one which we look for. We look for proper interpretation of the results and proper way of presenting it. You need to justify. If I say that, okay, the efficiency of this system improves by about 5%, I need to justify that. So it can't be like a hand waving. It gives 5%. No. I need to justify that. So that's very important. So results and discussions, generalization, interpretation, drawing conclusions, and of course you end up with the writing the thesis. So research problems are of two types in the research problem formulation. So those which relate to states of nature like the environment states, whether it is pressure dependent or temperature dependent, or those which relate to relationship between variables. So possibly you will be varying like, the flow rate, fluid flow rate, okay, or the fluid temperature, fluid velocity, pressure, so on and so forth. So the researcher must decide the general area of interest or a subject matter that is interesting. That's what I said before. So as I told you before, you can see that initially to start with, the problem may be stated in a broad general way, and then it may be refined later on. How do you define? To start with, possibly you may have to undergo about 4 coursework, okay, which you will have to complete maybe in about a year's time, I guess. Okay, that depends on whether it is full-time or part-time. Okay, anyway, you'll all know about it. So what happens initially for about 1 year to 1.5 years, you will be spending time in, doing your coursework, and parallelly you can start your literature survey. So to start with, you need to have some kind of a broad area. And you're going to make a presentation in the first doctoral committee meeting that this is the area in which I would like to work. So the doctoral committee is going to suggest you based on your area of research. They are going to suggest you some 4 or 5 coursework based on your research area. Then once you start doing parallelly the literature survey, then you will finally end up refining your topic. You're not going to change the topic, but you're going to refine. And you're going to have a clear picture on what exactly you're going to do as part of your PhD research work. So you can start with the broad general category, and maybe you can see that then the feasibility of a particular solution to be considered before setting up a working formulation of the problem. And 2 steps are involved in formulating research problem: understanding the problem thoroughly, that's very, very essential, and rephrasing the same into meaningful terms from an analytical point of view. So the best way of selecting a problem is, if you have your own idea, okay, otherwise you can discuss with your colleagues or those having some expertise in the domain, or to discuss with guide in case if you have already chosen a guide. Possibly guides may have some problems to be solved, and you can choose one of the problems given by your guide. Or possibly if you want to work on really, your research should be contributed for the scientific humanity, then possibly you can approach some industries, because nowadays industries are willing to give the problems to be solved by the academic institutions, like what's happening elsewhere in the world. So researcher must also examine all available literature to get acquainted with the selected problems. So formulating or defining a research problem is a step of greatest importance of research. So problem to be, I think it's repeated. First, state the problem in general terms with respect to some practical, scientific or intellectual interest. This should be the focus. And problem to be investigated must be defined without any ambiguity. Without any ambiguity. So, now, how to do a thorough literature survey, a proper literature survey? As I told you before, literature survey is very, very critical for research. Even if you look at industry, they want to do some kind of a research, they thoroughly do a research, thoroughly do a literature survey to find out what technological developments have happened in this particular domain in the rest of the parts of the world. Now, how we can have those technologies adopted for our Indian conditions. And this is where the literature survey plays a very, very important role. And check to see if your idea is original. It's only from the literature survey we can find out whether your idea is. So get articles, read articles and the references. Now, this is where I would like to, insist upon, you collect a lot of papers, but when you go through a paper for the first time, I am for sure that you won't be understanding more than 15 to 20% of the content present in the paper. So if you want to have a thorough understanding of a particular paper, possibly you will have to read at least about 4 or 5 times. So read articles and the references. References I'll come to a little bit later. And most of these will be vital when writing up reports. I will tell you why it is vital for writing up the reports as well. So, and by doing a thorough literature survey, you find where do you have the research gap. This is where, as a researcher, when your thesis goes for the evaluation, or when you present it to the doctoral committee members, so they will ask for what is the newness in it, what is the novelty that is involved in your research work. That's very, very important. So find research gap areas, find obsolete measurements and results, and define the objectives of the study. I'm not going to go through this. I have just pulled up from one of my PhD scholars' thesis, just to highlight on how you will have to go through a paper. Now, if we look at the structure of a paper, I think someone is going to talk to you about on how to write a paper. Right, so if you look at the structure of a paper, we start with the abstract, okay, which will give an idea on what is that, the researchers have contributed, and what is the global scenario in this area, and what are the findings of the researchers. Then we will have introduction, which will give a brief on what kind of work has already been carried out in this particular area by various researchers around the world. So that's what you can see. Probably you can see some figures are given in brackets like 1, 2 to 4, and 5. Okay, so you can see the one you find on the 5th line, right? So the first 4 lines were given by the authors of a paper, from where the authors who have presented this paper have drawn. Like I told you, most of the points I have taken it from the internet. Like that. Assuming that, okay, of course, this is pulled out from one of my papers, one of our papers along with my research scholars. So you can see that, in our paper, so we have drawn some statements, right, from somebody else's paper. That somebody else is given in reference 1. I will come to that a little bit later. So likewise, you can see that some inferences have been drawn from various literatures by us. Okay, so which are the literatures wherein we have drawn these inferences? You can see reference number 2, reference number 3, and reference number 4. Likewise, reference 5. Likewise, 6, 7, 8, 9, and 10. So what is that we are trying to give it in the introduction part? Is that pertaining to my area of research, what work has been done by others. Okay, so every paper will have an introduction part. So if you can go through that introduction, that will give a clear picture on what has been done in your area of research by others. Yeah, these are the references. Now I showed you by within bracket 1 in blue color. Okay, now those inferences have been drawn from reference 1. I showed you another 4 to 5 lines, 2 to 4. So those inferences I have drawn from references 2 to 4. Okay, now, while doing a literature survey, now what happens is, usually, the PhD work will involve at least about 3 to 4 parts. At least about 3 to 4 parts. Okay. Now, assuming that I would like to present my research work in journals, so I will publish the first part of my research in one journal, second part in another journal, third part in another journal, fourth part in another journal. Now, what I will try to do is, in the second part which I publish, I will refer the first paper which I have already published, stating that as discussed in this paper. You wouldn't know what has been discussed unless you collect the first paper. So like that, third paper, I would have indicated as presented by the authors in the earlier papers. So which means that if you want to understand the third part of a work, you need to have understanding of the second part of a work which is available in some other journal, and the first part of a work which is also available in some other journal. So which means that, so like this, it's like a chain wherein if one particular topic has been made available in the form of research articles in different journals, probably you will have to collect all of them, then only you will be able to understand what exactly the authors have done. That's very, very important. Okay. So if you look at this, you can see that how do you collect the literature? Like, for example, if you look at the reference 1, the third line, Fuel 2020, meaning that it is a journal of fuel which had been published in the year 2020, and volume number is 278, page number is 1,18,319. So what you need to do is just copy starting from fuel and paste it in Google. Click it on, you will get the paper. Or if you know the title of the paper, you can straight away put it, in case if you don't have the papers, page numbers or volume and things like that. Yeah. Literature survey, you need to record it in the beginning itself. At least for my research, I would have collected anywhere between 50 to 60 papers in 1992, 50 to 60 papers. And you can't imagine that, every time you can go through the papers again and again. I said 5 times per paper, 50 into 5, 250 times. Of course, we have to go through that. But every time you cannot go through the entire paper, right? So what I would suggest is possibly you can maintain a notebook. So wherein you can have, this kind of a tabular column. Nowadays, you have computers, you can even, just straight away type it. Like you can just start with the authors, the title of the paper, what are their observations, what are the conclusions. So like this, if you maintain a record of all the papers which you have collected, then every time you don't have to go back to go through the paper fully. You just, look at this. Automatically, whatever you have read, it will come to your mind. And this will also be helpful when writing your thesis. So it will serve the dual purpose of, you don't have to go through again the literatures, and also it will be helpful for writing your literature survey part of your thesis. So wherein, you can just reproduce this in the form of, sentences. So literature survey is very, very important. Yeah, where and all, whatever has come to my mind, I have just, put up in the form of points like, you can collect papers from refereed journals. So what is important is the refereed journals. Conference proceedings, reports, books, or some kind of technical articles, those are published in some magazines. Yeah, so that's what I told you, no? Whenever you go through a literature, possibly, something will stuck your mind, like why these researchers have approached the problem to solve it in this way. Why not this way? Catch that point. Why not this way? That's the reason why I said that you should always ask 5W1H. Okay, who did that? Why they have done it? What they have done it? When they have done it? And where they have done it? And how they have done it. I mean, it's not only mentally, but even when you do experimentally, you have to, visualize where this has been introduced. What are the conditions in which this has been introduced into the system? How it has been introduced? Where, in which location it has been introduced? So, such type of questions should come to your mind while doing the literature. So I have just given an example of what we did about 10, 12 years ago, one of my research scholars, and you can see that finally towards the end of the literature survey, you can see that from the investigation of previously published works in the literature, the following research gaps were identified. Okay, reduced reaction mechanisms, higher alcohols were not used as a fuel. Then we have, you can see last point, most of the research has focused around traditional fuel and the blends. So this is where you can see that based on the research gap, the objectives have been very clearly put forth, stating that these are the objectives to be met from my research work. Now, I can have these objectives very clear only if I do a thorough literature survey. Okay, so coming to the experimental study, as I told you before, you need to first find out where exactly you're going to carry out your research, whether it's going to be at ANA or probably in some industries in case if you have some kind of industry problem to be worked out, or probably in your institution. And check for the availability of various systems. இதுவும் வராதுன்னு நினைக்கிறேன். இந்த இதில் எந்த பாயிண்டரும் ஒர்க் பண்ணாது, எல்இடி இதில். அது இதுதான் ஸ்க்ரீனில் தான். Thank you. So, you need to check for the availability of equipments, analyzers, instruments, sensors, actuators, and whatever. So, you only know what you need. So, design of those who perform experimental work, design of experimental setup is important. Because once you have set up your objectives, now you should know what kind of experimental work system that you need to design. And you know where and all you need to have the sensors like the pressure sensor or the temperature or the velocity sensor, so on and so forth. Okay, it need not be very precise, but it can be just a skeletal experimental work to start with. Yeah, then you can have the experimental test matrix. That is, what are the variables that you are going to change and what are the conditions in which you are going to operate the system. Okay, just to give an example here, you can see on the left hand side we have the variables like, I said we work on engines, and engines, two major variables are the load and the speed. Okay, so we have all those things on it. And you can see the fuels used. So we try to make use of different fuels. You can see the fuels used are listed in the center column. And what is that we expect? What is that we are trying to do? Like you can see in all these cases, comparison of performance, emission, and combustion characteristics, making use of a particular fuel. Then evaluation of the performance emissions, evaluation by varying the parameters. So Like this, to start with, you can have, again, a skeletal. It need not be very precise. Over the period of time, you can refine this, because the more and more literature survey that you do, you will find that your problem can be refined. Yeah, so theoretical study, this is where I said, you can mathematically model any system. Okay, so mathematical models are essential part of simulation and design of the control systems. Today we have MATLAB, and like that we have many models available. Like I said, ANSYS, those who work on fluid dynamics, we have ANSYS. Then we have other softwares like Fluent ANSYS, okay, something like that. So when we look at mathematical modeling, you can see that it's a simplified representation of reality. I told you, we can model the air conditioners. What are the important things that we need from the air conditioners? We need to have a humidity of about 55 to 60%, and we need to have a temperature of about 25 with plus or minus 1 degree Celsius. And you need to have a good uniform distribution of the air in a particular chamber. Now, all these things could be modeled, unless what you are trying to do is, you can see that you are modeling a reality. Like, today people talk about augmented reality and virtual reality. Virtual reality, you talk about, having some kind of goggles, and, you have some kind of, cricketers playing this, that, and all. It's virtual reality. Or you play some sports. Augmented reality today, we make use of 75% real world and 25% virtual world. Like, for example, just to give an example, nowadays, we have even the third umpire is not able to take a decision. So we have another umpire who is sitting in the pavilion. Okay, so who enlarges whether the bails, the batsman has reached the crease or touched the crease even before the bails have been knocked out of the stumps. So we blow up. That's augmented reality. Okay, so like this, what we are trying to do is, we are modeling a reality into picture, and to resemble the relevant features of the system being analyzed. So through mathematical modeling, real world is translated into a conceptual world. Okay, and theoretical study requires a lot of knowledge. That's what I told you. You need to have theoretical knowledge as well as the physical working principle of a physical system. Unless you understand the system, you may not be able to have the initial or the boundary conditions. Like you can see, possibly you can go through that later on. So we need to have a mathematical model. We need to have some governing equations. Invariably, what I have come across is, with most of the research scholars who do the theoretical modeling work as part of the research, if we ask them why the behavior is like this, they will say, I don't know, sir, the system has given. It's not acceptable. How you can justify stating that, okay, the performance is improved, unless and otherwise, the physical system, you cannot. So this is where the governing equations, we need to define the equations, and we need to have a relationship between two physical quantities. So all these things put together with the physical laws, and we need to give the initial condition, that is at time t equals 0. This is what is the condition. The pressure inside the system is so much. The temperature inside is so much. Then only the model or the simulation is going to give you some good results. And we also need to define the boundary conditions as well. And we need to look at the constraints of the system as well as the kinematics, depending on the area in which you work. But what is required for theoretical study is, you need to have a high-end system, maybe a workstation in certain cases, and of course high-end softwares. So as I told you before, what is expected out of research is that, novelty or the newness or the improvement in the process. Most of us have a feeling that, research should always be positive. When I try to work on a system, there should always be an improvement in the performance, not necessarily be. That doesn't mean that, somebody has already proved that, this gives a lower efficiency, and again, you do that and say that, this gives a lower efficiency. No. You can try to improve upon the process, but in the process, if the system performance deteriorates, it doesn't matter. So that's what I said initially. You are providing data to the research or the scientific community. And of course, new information to the research or the scientific community. Research has no age. I don't know how many of you have seen this last week Times of India paper, wherein a Karnataka person, the age of 79, was awarded a PhD degree from Victoria Technical University. One of my PhD scholars completed his PhD at the age of 74, which only indicates that, there's no barrier for research. Okay, so this is a very important document. Okay, so wherein you find that it's too early for me to, talk about what you need to find out. Probably, I guess these slides would be shared with you all. So I think you can, in case if you feel that, you can always contact me. I have given you. See, I have guided about 26 PhD scholars so far. After guiding about 6 to 8 scholars, I felt that, I have understood where and all my research scholars have failed in writing the thesis. Then I decided that I must prepare a booklet on how to write a technical thesis. So in 2014, of course, it is only meant for internal circulation for my PhD scholars and for my PG scholars. It's about 25 to 30 pages, I guess. So those who are interested, you can contact me. Of course, it's pertaining to only internal combustion engine, but you can have that as a broad guideline, and you can write your thesis accordingly. So to summarize, so you can see that you need to state the problem in a very general manner to start with, and understand the nature of the problem, survey the available literature, develop ideas, rephrase research problem into a working proposition. So again, I would like to close by some of the quotes by, you can see, Albert Einstein. He said that imagination is more important than knowledge, and knowledge is limited, but imagination encircles the world. Neil Armstrong had said that research is creating new knowledge. Research is to see what everybody else has seen and to think what nobody else has thought. This was by a US biochemist, Albert St. Gorgie. If you knew what it was we were doing, it would not be called research, would it? Put forth by Albert Einstein. And everything is theoretically impossible until it is done. This is what is said by Robert Heinlein. A good researcher would be a good teacher. Do you all agree with me? How many of you teachers here? You know who said this? Okay. Right, so I think I have done with it. So I would like to thank the directors, the deputy directors who happen to be the coordinators and the co-coordinators of this 3-day induction program for giving an opportunity for me to share with you on the experiences, what I have gained over the years. And of course, wherever I make a presentation, I don't forget to make a mention about these 4 great personalities. And they are the inventors of, internet, like Larry Page and Sergey Brin. Bob Kahn and Windsurf, They are the inventors of Google. Today you can get everything from the internet and Google. But what is important for people like me to collect the information from internet, Googling it, and making it in the form of a beautiful slides by copying it and pasting it here. It is Larry Tesler who invented the copy and paste technology. Okay, so thank you very much for your patient listening. So that's my contact. If you feel that if you would like to communicate with me on any kind of assistance in future as part of your research work, I'll be too happy to do that. So I told you in the beginning that I will share my experience. I'll just take 1 or 2 minutes. In 1992, when I registered for my PhD, I was very, very, optimistic in the sense, I wanted to work on ethyl alcohol or ethanol as an alternative for diesel fuel. That was in 1992. I was very optimistic. I thought, okay. But later, I found out that getting ethanol is not that easy. Because 1 liter of ethanol, which cost about 20 rupees, can be converted into a foreign-made liquid worth about 2,000 rupees then. 20 rupees getting converted into 2,000. So there were a lot of prohibitions in terms of getting a license for procuring this ethanol. And there was a procedure involved. I need to apply to the government through the Tahsildar, then it goes to the central prohibition. It took 5 years for me to get the license. So what I'm trying to say here is, be optimistic, but don't be too optimistic. Okay, so that's why I said that a thorough literature survey, right, will assist you in choosing a good topic, and so that you can come out with a good research work. That's all I have to say. If you have any questions, I think I will take it up, and otherwise I wish you all the very best. So possibly in about 3 to 5 years time, I think you should all be coming out as a good researcher. Thank you very much. It's open to questions.
Thank you, sir. So I think the first session has set the tone for the entire 3-day induction program. And the ideas that sir has presented today are relevant to any discipline that falls, because I was able to relate to most of the ideas that you said and how important it is. I have noted down the technical writing model that you have kept for the thesis. We are soon going to ask it from you, sir, so that we can share it for the benefit of scholars. So a couple of questions from scholars regarding what sir has spoken on research design and methodology, something that is very important before you start your research. So usually our scholars are all very curious, they know that they cannot meet these people otherwise, so they ask us a lot of questions. I hope that this batch of the PhD scholars will also be curious and ask questions. Not just scholars from mechanical engineering background, any engineering stream can ask. Because this is a very general topic, right? Research, design and methodology. Can we have a couple of questions? Yes.
Good morning, sir. Thank you for the wonderful lecture.
Thank you.
So, my question is, I am B. Satya, doing a PhD in physics from SSN College of Engineering. So, initially, we found difficulties in taking doing literature survey, sir. So, in the first point, you said to check whether our idea is original. So, what do you mean by that? What do you mean by original, sir? What to check in our idea?
Okay, good question. So, possibly, I don't know whether you already have a problem in your mind or problems in your mind. Do you have any problem in your mind to be worked as part of your research work? That's what can you come out with that problem?
So, my field of work is like photocatalysis, sir.
Photocatalysis, okay.
So, in that, to be specific, we are working on graphene-based material to deal with wastewater treatment. Graphene-based and its derivative materials.
So you're going to work on materials.
Yes, sir.
You're going to work on alternative materials.
Yes, sir.
Right?
Yes, sir.
For treating the wastewater.
Yes, sir.
That's what you're
in
doing.
general, sir. This is
okay. I am okay with that. Okay. I don't want you to be very precise now. I won't accept that. Okay, like that's what I said, Now, you said you have some materials in mind. How do you know that whether these materials have already been tried out by somebody else? Okay, so this is where literature survey. Now, even if you look at the material, what you have in mind, somebody else would have worked. Maybe they would have adopted a different methodology. Same material, different methodology. Probably you will have some other methodology in your mind. Now you try to search for the literatures wherein the methodology for the same material which you have in mind has already been tried out by someone else. Okay, so that's why I said, if you are sure that yes, you have done a thorough literature survey, right? Now you can straight away start working with your materials with different methodology. You understand?
Thank you, sir.
Like just to give an example, you are a physics person, right? So today we will talk about, batteries, lithium-ion batteries. And today people are working on zinc, sodium, which not many people have worked on. Okay, just to give an example. Holograms. About 15 years back, 20 years back, it used to be very popular. There were not much of work has been done on holograms, right? Physics area. But today you find there are a lot of research work has gone in holograms area. Materials. That's what I try to say. Yeah, she has.
Hello, sir.
Yeah.
I'm Kalayarasi from Rajalakshmi Engineering College, doing my part-time PhD right now. So the session was so impressive and it was wonderful, as everyone was thinking. And I would have some basic question that if we go for some literature survey, if we find some journals, how will I identify it as a quality journal, which I'm going to look it for? The paper, this is a quality journal where I can go through. And this is not as, in the initial lecture, initial session, they were identifying as Q1, Q2, Q3, Q4 journals. So if I'm going to look into the journal, whether I can go further into it or shall I just cut it off?
Very good question again. So this is where, the impact factor plays an important role. Okay? And you look at, I don't want to name the publishers, you should find out, the journals are published by whom, whether they are prominent publishers. Okay, so that needs to be taken into account. But here, that's what I'm saying, See, if you look at some, poor quality journals, you will find that, you won't be able to get that much of information. That's why I suggested some refereed journals. Now, here again, I would like to say, as I was making a mention that, if you can divide your research into 3 or 4 different parts, okay, once you get your first part completed, try to publish in some good journals. It will never get published that easily. But it will go to the reviewers, wherein the reviewers will critically examine your paper and they will give you a thorough report. And that will set a base for your research. Okay, those could be your points. So whatever that you haven't thought about it, those things will come out from these reviewers. Okay, then you start, doing that as part of your research. And finally, your thesis will come out in a beautiful manner. That's the reason why I always suggest that you go for refereed journals for publication of the papers.
Okay, sir. Thank you, sir.
Okay. Yeah, thank you.
Thank you for your patient answering.
Anybody
to all
who
the
has
questions
question who are
online?
participating in online?
Is there a question from the chat box?
They shouldn't feel that they have been left out, right?
Yes. They are checking, sir. So like she asked, how do you identify standard journals in any field? I think most of the other sessions will also try and answer these questions. So online participants, if there are any questions that you would like to ask to our resource person, you can please type it in the chat box. If there are any questions, you can tell us. So far, no questions. Okay.
So I'm a beautiful teacher, and usually there won't be any question.
Yes, sir. Thank you, sir.
Okay.
Thanks a lot.
Thank you very much.
Thank you
It's
for
my
setting
pleasure
the
to be
right
here.
tone for this induction program. Thank you, sir.